Alright, down to our last couple sections of chapter 2. So for this one, we are now solving rational equations. So that just, again, that just means we have an x in a denominator somewhere. For these, pretty common approach that we're going to be taking all the way through. The idea is we don't want x on bottom. So whatever our common denominator is, we are simply going to distribute that throughout the whole problem, and then we should no longer have a fraction. So on this one, our only denominator is x. So what they did was they multiplied everything in the equation by x. So it looked like this. And in doing that, so this would become 2x squared. These x's would cancel, and I left with just the minus 1. And then I have equals x on the far right. And so that's where they got this equation from. From there, we are just solving a quadratic, right? So we subtract x over, make it the whole thing equal 0, and then we can solve by factoring, or you could solve by the quadratic formula. Any of that is good. So we'll be doing some of these for practice in just a minute. I just wanted to remind you of kind of what this process looks like. This would have definitely been something you saw in Algebra 2. So let me jump down to this guy. So same idea, we're solving this rational equation with x in a denominator. So I want to take the common denominator, which is x minus 3, and multiply it through to the whole problem. So here's where it started. So if we take x minus 3 and multiply it through, so I would be multiplying this whole equation by x minus 3. So when I multiply that times my first term, it would become 2x squared minus 6x. When I get to the middle term, my x minus 3's would cancel, and I'd be left with just the minus 1. And we get that quadratic equation right there. So we don't have to fill in the second line. I kind of distributed as I went. So I already took care of that part. So here's our quadratic equation. Everything's in order. It equals 0. So now you could solve it. This one is not factorable, so they went on to solve it with the quadratic formula. Came all the way down to this, which we could leave our answer like this. If the directions say to round it, then we would follow the rounding rules, whatever the directions said. If directions don't say, then we would take either answer. Let me keep it moving for you. So for this example, I have 2 of these that would be good for you guys for practice. So we're going to do these on the next page. I created a next page of space for you to do work like this. So we're going to do 8 and 11. And then I will come back. So always good time to pause, give these a try, see how you do. As I look at number 8, my common denominator would be x plus 1. So we're going to take the x plus 1, and we're going to distribute that throughout the whole problem. So as I distribute it to my first term, you can see right here that my x's would cancel, and I would be left with the 1 times x plus 1. As I get to my second one, you can see that the x plus 1's will cancel, and I would be left with just the 1 times x. On the far right, nothing cancels, so it's just the x times x plus 1. Alright, so there's the new equation, and remember the whole goal on this was as you distribute, the fractions should cancel. So you get a new equation with no fractions in it. So let's combine like terms. So left side I'm looking at 2x plus 1. Right side, if I distribute, I got my x squared plus x. So right off the bat I'm seeing the x squared, which means this is a quadratic. Let's get everything onto one side, make it equal 0. So I will subtract the 2x over to get this, and subtract the 1 over to get this. And as I look at those, that would not be factorable. So let's throw that into our quadratic formula. So I've got my negative b plus or minus b squared minus 4 times a times c over 2a. So this is what we'd be looking at. So under the radical, 1 plus 4. So 1 plus or minus square root 5 all over 2. And I'll just leave it like that for now. Obviously, if you get directions that tell you about rounding, then follow those directions. But I'm going to leave it like that. Here's one thing I want you to keep in mind. As I go back to the original equation, what can x not equal? Right? Based on this, x cannot be 0, and x cannot be negative 1. So if you get any of those, either of those as an answer, you cannot use it as an answer. So always something we're on the lookout for when we're doing these. All right, as you see ones like number 11, you could take the same approach and say, okay, my common denominator is 3x, 2x minus 1. I'm going to multiply through that to everything, and that's just fine. Probably the easier way to look at these, if you go back to a method that you're very familiar with, would just be to cross multiply. Anytime it's just a fraction equaling a fraction, you can just see it as cross multiplication. So I'm going to multiply my 2x minus 1 times 2x minus 1. Let's see, 4x squared minus 4x plus 1. So I got that on one side, and on the other side I am doing 3x times 3x, so 9x squared. Always good to keep in mind values for x that we could not use. Cannot be 0, cannot be 1/2, right? So keep that in mind. If we end up with either one of those, we got to throw that answer out. So let's get everything onto the right side so that my leading term is positive. So if I subtract over the 4x squared, it would become 5x squared. Add the 4x, subtract the 1, and we have our quadratic to solve. You could factor this one, 1 and 5 looks like it is factorable, or you could use quadratic formula, whatever you feel more comfortable with. Let's do a little negative b plus or minus square root b squared minus 4 times a times c all over 2a. So under the radical, I'm looking at 16 plus 20. So that would be 36. And that's how we know it would have been factorable. If you get a perfect square under the radical, that means this guy would have been factorable if you would have factored it. So obviously square root of 36 is 6. So if I did negative 4 plus 6 over 10, that would be 2 over 10, which is 1/5. And if I did negative 4 minus 6 over 10, it would be negative 10 over 10, which is negative 1. And remember, we already looked at the numbers that I can't use for x, and we're safe with those two. So those would be my two solutions. So let me go back to the previous page. So when they talk about extraneous solutions, that's what I was referring to as far as values for x that you cannot use. So if you look at this equation, so if you look back up here, based on what I'm seeing already, like I know already I cannot keep numbers like positive 3 and positive 1. We'll factor this guy out, but that's what they're talking about when they mean extraneous solutions. So what they did on this one is they put this in factored form, right? So it became x minus 1, x minus 3. So the common denominator is x minus 1, x minus 3. So they distributed that to the left side. They distributed it to the right side. Remember, we cancel as we go. So if you look like at this one, when I distributed it to the first term, which is this, I know my x minus 3's canceled, and I was left with just the x minus 1 times x. So that's what you see right here. When it was distributed to the second term, my x minus 1's canceled, and I was left with just the negative 4 times x minus 3. And that's what you're seeing right here on the far right. This is the denominator, so the whole thing cancels, and I'm left with just the 8. Right? From there, we're going back to basic quadratic solving. So what they found on this was their solutions were positive 1 and positive 4. So if we look back at the original equation, positive 1 is extraneous because it does not work if we plug it back in. So we have to throw him out and only keep 4 as our answer. So that's all they were saying down here is this guy's an extraneous answer, so we're only keeping x equals 4. So let me go on. So we have an example for that. That is this guy. So first things first, we definitely want to put things in factored form so we can see what the common denominator would be. So if we factor this guy, x minus 2, x minus 4. As I look for a common denominator, remember the idea is I basically just want a denominator, a multiple here that will cancel all of my denominators, right? So what will cancel out the x minus 2, right? Obviously x minus 2. So that will take care of the x minus 2's. What else do I need to be able to get rid of? I also need to get rid of an x minus 4. So we need him as well. So now as I look at those two factors, I can see that it's going to cancel him, it's going to cancel him, and it's going to obviously cancel both of those, so I know I'm good. So now as I distribute, I cancel as I go. So those two guys are gone. I'm left with just the 4 times x minus 4. Minus. Right here I got the x minus 2's that would cancel, so it's just the negative 1 times x minus 4. On the far right, everything cancels, and I'm left with just the 3. So a pretty simple equation now that we can solve from here. Watch out for those signs. Always good when you write stuff like this to write it with parentheses, just to help you recognize that this negative that we brought down belongs to all of this. Right, that's important. So keep going on this. So 3x minus 12. So 3x is 15. X is 5. So as we look back, again, just checking for extraneous solutions. We could not use positive 2. We could not use positive 4. I did not get either one of those, so the one answer that we did find is good. And a quick side note, in case you caught this earlier, you might have noticed that these two fractions do have common denominators. So if you would want to, you could combine these and then just do the 4 minus 1, which is 3, over x minus 2. So you could have combined this into a single fraction of 3 over x minus 2 and then just cross multiply. That works too. It's just however you see it best. Alright, so that's the one that we just did on the previous page. So let me continue on. So a little fun with word problems here. So find the dimensions of rectangle minimum perimeter if its area is 200 meters squared. Yeah, future calculus stuff. I think we talked about that with some of our previous chapter stuff. Will be whenever you see maximums and minimums, those can all be done with derivatives when we get to calculus. So we're gonna solve this guy graphically. So see what we got here. So we're talking about perimeter and area. So we're gonna need two formulas that we're gonna need to put together to be able to solve. So consider our rectangle. So if we just think of this as maybe x times y. So as far as the area goes, we know it would be x times y. So one of the issues on this is I got too many variables floating around in here. So we know the area is 200 So what they will do to get rid of the y value is they will say, well, what if I isolated the y? So if I divide the x over, then that tells me that 200 over x is my y value. So in my formula right here, instead of having y, we're going to put 200 over x. So let's kind of put all that together. Here's my area, and it's that times that, except instead of a y, we're going to put 200 over x and write it that way. So now we have an equation with just one variable in it. Yes, I see that those would cancel. We don't want to do that, though. We want to use this to further our problem. If we look at, so from now on, let's consider this to be 200 over x instead of y. If we were looking for perimeter, remember perimeter would be 2 of those plus 2 of those. So it would be 2 x's plus 200 over x's as far as our perimeter setup goes. So let's just do a little cleanup on that. So for perimeter, let's call it the expression 2x plus 400 over x. So the whole point of them giving us information about the area was so that we could create this information. So now as I go on to write my perimeter setup, I only have one variable involved, right? So that's how we use the area formula in order to set up the perimeter formula. Ultimately, the question was talking about a minimum perimeter. So until we get to derivatives, we are still solving these graphically. So we are going to put in our function that we just created. And the window on these is an issue. So I already figured out a good window that we could use. So I'm going to go into my window settings. I'm going to go from 0 to 50. And on my y's, let's go from 0 to 150. And that's where we're going to graph it from. Remember, the idea is I should be looking at a curve with an obvious minimum point, right? And so that's why I ended up with the window that I have now. I kind of kept playing with the numbers until I could see, oh yeah, there's my minimum point right there within that graph. So how do we find it? We go into Calc. We choose minimum and set up my boundaries. So left boundary, just make sure you are to the left of your minimum. Right boundary, make sure you are to the right of your minimum. And hit enter. So one thing to consider in this is, what were they asking for? Right? So this problem specifically said, find the dimensions of the rectangle. Okay, so I need to know, essentially I need to know my x value, so I can put it here, and that will tell me what my dimensions are. But that's always something to read very, very carefully. They could have said, what is the smallest perimeter you could have had? Well, that would be this guy, right? Remember, because in the function that we just graphed, my x represents a side length, but my y value represents the perimeter. Okay, so they could have just said, what's the smallest perimeter? And we would have used this number. But this one said, what are the smallest dimensions? So I would put this as one of the dimensions. And then if I did 200 over this number, that would give me the other dimension. So we're just going to be solving those still graphically for now. And that is it for 2.7. So we'll get into 2.8 in the next one.